speak, but I'd like to introduce Bill Gordon, who is coming to us from Queensland this morning. He works for New Farm these days. He's a spray application specialist, and Bill's been playing with spray application for more than 20 years, and recently moved over to New Farm, where he does that as well as other things. So good morning to you, Bill.
Good morning, Peter. Good morning, everyone.
And thanks for joining us. And look, I'm not going to carry on too much more. This morning is all about you telling us about spraying wisely. Bill, last week we heard about vapor drift. This week we're going to hear a little bit more about, well, you can tell us about it, but it's minimising spray drift while maximising efficacy, which is the fine line that we always tread. So I'll hand over to you, Bill, and you can tell us more about yourself, and we'll pause for questions as we go.
Thanks, Peter. Morning, everyone. Yeah, I've been moved across to New Farm about a year ago, and obviously working as a spray application specialist with them. Part of my role with them is to get information out about application techniques and also about products and timing. So part of what we're talking about today will be the bits of minimising drift, but also maintaining efficacy. So I'll move on to the next slide, which is just a couple of take-home messages. And I guess that the most important thing for most operators is that how you set up the sprayer and how you operate it out in the paddock will determine how much product will be left in the air. It's then up to the conditions what will happen to that airborne fraction. So there's a lot of things that are in the grower's control, but obviously the weather conditions are the one thing we can't directly control. And I just wanted to talk a little bit about that difference between air movement at night and early in the day, being very different to what you get during daytime itself. And I'll talk about that and some of the tools that we've developed to help people understand that. I'll also spend a little bit of time talking briefly about the nozzles and how they might respond to tank mix or adjuvant, how that might increase or decrease drift potential. And the last little bit will be on just tools such as water sensitive paper and things like the Snap Card app for assessing coverage as a way of improving efficacy. So they're the main take-home messages, and I'll sort of move through the slides, chat, and have a short break every so often to see if there's any questions. I'll check in with Pete. So we'll get started. I guess when we think about those factors that can actually influence spray drift, particularly over summer, the weather really is that key driver, not only in terms of heat and evaporation during the day, but also air movement and where it can carry droplets. So the weather conditions, as I mentioned before, are really important. All of these other factors that are on the screen, including your choice of nozzle and pressure, how you operate it, so the spray quality, the product choice itself and the rate, including the water volume, how sensitive crops or other things around you may be to that particular product, your adjuvant choice, the boom height, the spraying speed. Now those bottom two factors, the boom height, can have a huge role in how much may stay in the air, as does the spraying speed. So the higher the boom, the faster you travel, the more product you'll leave in the air. Just moving on to one of the drivers, or one of the pieces of information that's been used widely around the country about making decisions for spraying, and that's delta T. And I guess what I'm asking there is, have we done the right thing by emphasising delta T? Certainly we know that it has a role in evaporation of droplets, and it also has a role in plant stress. But as we progressively move to using large droplets over the years, in other words, moving into coarse spray qualities and larger, our droplet survival is actually much better than we think. So, having a strict cutoff or stopping at a particular delta T or temperature may not make sense if we're already using a large droplet and the plants or weeds that we're trying to spray aren't actually stressed. And that's probably the key to it, is understanding when the weeds themselves become stressed. So I'll just move on to the next slide. Here's some trial work done by Peter Both, one of the R&D guys from New Farm. This was done a couple of years ago looking at control of potato weed and caltrop that's done in South Australia. And what Peter did was use spray-wise decisions to look at when we expect delta T to increase rapidly a couple of days out, so we could actually plan this trial. And you can see on the graph on the screen that we have a percentage efficacy on the weeds that were present, and throughout the day at different delta T values. So a delta T of almost 4, 6, 9, 12, 14. That efficacy didn't actually suffer in this trial. That's because there was good soil moisture present, the weeds weren't actually stressing. So if we want to be able to push conditions to get more daytime spraying done, we need to be able to actually assess the weeds in the paddock and what sort of condition they're in, as well as have an idea of when they're likely to stress. So again, using larger droplets at core spray quality, you can manage delta Ts up to about 12 comfortably, but you can still get efficacy a little bit further provided the weeds themselves aren't stressed.
So that was the question I was going to chime in with, Bill. Is that roundabout? So in the past, I think the cutoff has been more around 10, but you're saying that if conditions are good, you can push it to 12 or maybe 14?
I think once you get to that 10 to 12, your coarse droplets will survive pretty well in that sort of circumstance. Once you push beyond that, you really need to have good soil moisture there and plants not to be stressed to be able to push it further. So just stopping at a particular value, because that's, you know, on a table or a hard and fast rule, without assessing the conditions of the weeds themselves, you may actually be limiting some of your opportunities for spraying during the day, which are actually the safest time for spraying from a drift point of view. I've got one more example I might pull up and then I'll come back to that. So this is a trial I did a few years back, which was GRDC funded in one of my projects. And we're actually looking at heliotrope control as well as a few others. And this was either controlling with spray seed, so a contact type product, or with a glyphosate phenoxy tank mix. So these were commercial tank mixes. And there was 2 application volumes at 60 or 90 litres. We had a whole heap of different droplet sizes and nozzle combinations. And then I'll just take either desiccation at 24 days. So with the contacts, a range of medium or coarse droplets all provided pretty good efficacy at 60 litres, but increasing it to 90 with a really big droplet size, we actually saw a reduction in efficacy. But when we increased the volume, all those spray qualities performed about the same. Whereas for the fully translocated mix, increasing the volume didn't actually increase the efficacy. I just want to take you back to the delta T conditions when this trial was actually sprayed. Again, we had almost 100% ground cover there and good soil moisture. And so in this particular trial, we really stretched delta T. And it's showing that if you match the droplet size and the volume to the target, you can still get pretty good control, provided the plants aren't stressed. So, I mean, there's a lot of information there in that particular table, but I guess the take-home message is that, you know, match the droplet size and coverage and understand whether the plant's stressed or not. And you can actually probably push some of those conditions provided, like I said, you've got the soil moisture there.
So I guess, Bill, if we're in a situation where we've had a summer rain, it's germinated summer weeds, and they're growing away, and we're getting ready to spray, and we get another drop of rain, and everything is fresh and growing well, and we've got good soil moisture, and we head out with our weed seeker or weed it, you know, that's getting more and more common, or even, you know, bulk spraying. But in that situation, perhaps for those first couple of days after the drop of rain, we could push the delta T and spray, do a longer spray day to get over the ground. Is that a fair comment?
Yeah, I think that's exactly the approach I'd take, is that go hard and get as much done, particularly during daylight hours, once you can first get back on the country and things are still fresh. But make sure you're monitoring things closely and identifying when things are starting into that period of stress, because they're going to be much easier to kill while they're soft and fresh. And each day you delay, that challenge becomes harder and harder. So I think we are able to push delta T, provided we've got control of the droplet size and we understand the condition of the plants. But I take your point that getting more done early is a good strategy. Timing is everything. Then your rate of product, and then probably droplet size and application volume. But as things become more stressed, those other factors like rate of product and coverage become much more critical to maintain that efficacy.
Okay, thanks, Bill. And for everyone listening in, make sure you type any questions into the question box, and we'll pause, have some more questions. But back over to you, Bill.
I've just put up a diagram, or like a 24-hour risk profile for your summer spraying. This is something New Farm's just recently released under the SprayWise banner. What we're trying to do is probably simplify some of the messages. They're messages that have, sorry about that, messages that have been out in the industry for quite some time. And so it's actually a 24-hour cycle beginning at sunrise over here on the left, and then you move to sunset over on the right, and then looking at nighttime conditions, because a lot of people, are spraying virtually around the clock to get over country, particularly, the pressures things like double knocks put on people to get things done. What we're trying to do is identify the best times and hopefully get people to understand some of the times of risks. And so in the morning, you need the sun to get high enough to start heating the ground so that when the air moves across it, the air will actually mix or roll. In other words, you start getting turbulent flows when you've got a bit of heat in the ground and the wind speed's above about 4 kilometres an hour. And you get that rolling or mixing as it goes across the surface, and that's what brings droplets back down. So until you get to that point, you have a high risk of spray drift or droplets staying in the air and moving quite some distances. Then mid-morning through to midday in the afternoon, depending on the time, the conditions or the temperature on the day, that's obviously going to be your ideal conditions for spraying. If you're going to push into the afternoon, then you need to be aware of the increased risk of evaporation thermal activity. So think about your adjuvants, droplet size, maybe even water volume to help mitigate that. And then in summer, if you're actually able to have the wind continue to blow through sunset into the early evening, it's possible to continue spraying while there's still warmth in the ground. But as that ground continues to cool into the evening, your wind speed required to get the air to mix actually has to be a lot higher over a cool ground surface than it does over a warm. And so once your ground's cool, so your air temperature and ground temperature become similar, you actually need about 11 or 12 kilometres an hour wind speed at night to get that same mixing to bring droplets back down. And once you get beyond that point, it's getting really risky for spraying. So I guess into the evening, the thing you need to do is set up to minimise that airborne fraction as much as you can. And one of the ways of doing that is increasing the spray quality to coarser and coarser droplets. It is possible to get that airborne fraction to be really, really small with the right nozzle and adjuvant combination, but you can never completely eliminate it. And at some point in the evening, particularly when you get past 10 or 11, and that can change a little bit depending on where you are, most of the air flows after midnight until just after sunrise are going to be parallel to the ground and carry droplets along the way. So we try to put it in a nutshell to get people to understand that 24-hour cycle there and some of the risks that might occur. And I'll talk about the nozzles and droplet size in just a moment. But I was just wondering if you had any questions on that come in, Pete, or any comments.
There are questions, Bill. Yeah, and I think that's an excellent chart. And just from local experience here, I know very common where I'm based here near Geraldton is for growers in summer to get up at 2 or 3 o'clock in the morning and go spraying and knock off at 9 or 10 as it gets very hot during the day. And admittedly, we don't have a lot of sensitive crops nearby in those areas, but you would suggest that perhaps they're not doing the right thing by spraying at that time of the day, or can they get away with it with the right amount of wind? I'm just a little bit confused as to whether if it is, 4 o'clock in the morning and we do have 10 or 12 k's an hour of wind, is that okay to be spraying then, or is it still dodgy?
If that wind has continued to mix the air throughout the evening, it's probably still okay.
Mm.
And I guess the closer to the coast you are, the more air movement you're going to get because of sea and land breezes. So you probably have a slightly different situation right there at Geraldton compared to people that are 200 or 300 k's inland or further. You might actually be a little more fortunate. And if that wind is taking it away from sensitive areas, and as with most of WA, the wind speeds are pretty substantial most of the time, you probably have reasonable conditions for spraying.
Yeah, well, I mean, it is often quite still, even 50 kilometres from the coast at that time of day. So how much of that chart there, Bill, is about spray drift, and how much of it is about efficacy?
This is predominantly about spray drift. So it's a risk profile in terms of droplet movement, and letting people know what times of day are really going to be the highest risk for off-target movement. So from an efficacy point of view, your choice of products, if you are spraying into the evening, obviously it's got to be something that can be absorbed into the plant and potentially translocated. So I guess the efficacy side of things will be a little bit different to that. Some products will respond to spraying during the day much more, and there'll be a small group that will respond to spraying at night, either because of uptake into the cuticle or the actual how receptive the target itself is. Yeah. So yeah, this is predominantly a drift one, that one. And I might just expand on that with some information from the next couple of slides.
Well, can I just pause you? We do have a couple of more questions. There's two people asking, can we get that slide as a handout? Is that available online somewhere, Bill, that one?
I'll have to check where it's available online yet or not. I only got it hot off the presses about a week ago. I know we've shared it with some of the industry groups, and I'd be happy to send it over to you guys to put on your WeedSmart website, if you like.
That'd be great. Yeah, so we'll do that, everybody. We'll put that on the WeedSmart website and tweet it. Also, there's another question here. Should we be distinguishing between brews with and without phenoxy when you're talking about avoiding night spraying? For example, Roundup and Goal or Gramoxone, etc. Is that all right at night, but phenoxy during the day only? Is that a reasonable suggestion? Or I guess we're talking about spray drift, so they're all going to drift the same distance, but the phenoxies potentially can be very damaging to horticulture and sensitive crops, I guess.
I would agree with that, Peter, but I guess people need to be aware of what's actually on the label statements. And if a label says don't spray under surface temperature inversion conditions, and that red area we're highlighting is when they're most likely to occur, from a legal point of view, most products shouldn't be applied at that time. From a potential damage point of view, as you mentioned, then certainly your Group I products have the potential to cause more damage to broadleafs than some of the other contact type products. But at the end of the day, if they're moving off your farm and going somewhere else, they have the potential to cause problems. But some obviously cause more visual damage. But I've dealt with issues including fish farms and aquatic areas and all sorts of things that people probably wouldn't necessarily think that damage could be caused.
Yeah, and someone has commented that we need to consider what's downwind, but also I guess with inversions, it's not necessarily just downwind, is it? It can move in different directions in an inversion.
Well, I think predominantly they'll get carried with the predominant direction of the wind. It's when things become much slower and stiller that you'll get drainage to lower points in the catchment. So you need to be aware of both. But if you have, an 8 or 10 kilometre an hour breeze at night, that is actually a laminar flow or parallel to the ground because it's not mixing and bringing the droplets back down. Well, in 4 hours' time, that could be 50 k's away. 40 or 50 kilometres away. And so knowing what's immediately downwind is, useful during the day. 300 metres to a kilometre will normally be enough. But at night, you need to know what might be 10, 20, 30 kilometres away.
Yeah,
I'll
okay.
Put up the study in the next slide just as an example of that.
I do have more questions, Bill, so we'll just pause you there for a minute, because this next question's about a couple of slides back. So the chart with 60 litres per hectare versus 90 litres per hectare of water shows that less water worked better, even in higher delta T. How does that work? Saying, wouldn't you need more water to increase the amount of survivable water droplets? I'm not sure that there's much difference there. Maybe the glyphosate, a slight difference.
Where we have, sorry, there's no point me pointing at the screen with my finger, is there? Where we have A's and B's there, they're not significantly different, but that A was significantly different to that B. So in that case, there was one course that was actually better than the extremely coarse. But, where we have all the same letters there, a lot of those at high and low volume were equivalent to each other, but there were predominantly more of the higher volume ones were less efficacious. I think it comes back to the nature of the product, and products like glyphosate and some others, when the droplet is more concentrated, there will be more rapid uptake through the cuticle. So that may be part of the factor. We may also see that there's a higher surfactant loading in that lower concentration. There could be a number of things, but essentially I don't think there's a lot of difference between those two treatments with the glyphosate, other than that particular one with the green being better than the ones with the red. But where they all have A's next to them, those four are the same, and they're the same as those two. But that treatment was better than the red ones. So, and
one last comment here, Bill. Someone has commented that delta T can be misleading. I once sprayed when delta T was off the charts. However, I achieved one of the best results. If we strictly followed delta T, we wouldn't get much spraying done.
I think that's the message I was trying to get across, although maybe not the off the charts bit, but certainly if you're able to better judge the condition of the weeds that you're spraying, and you've got soil moisture there and you're confident they're not stressed, you can certainly stretch that. And I think this example that's on the screen at the moment, where the delta T was 14.5, 15.5, demonstrates it can be pushed at times. And I always think, after a rainfall event, when you can first get back on the country, you're better off to push the delta T then and get more done than wait, knock off at, 11 or whatever time of day it is, and come back again early the next day and early the next day. I would be stretching it out on that initial day as much as I could, and the following day.
Yeah, well, that's a great message. I've certainly learned something there, Bill. Thanks everyone for your questions. Keep them coming. We'll let Bill continue on for a little while now, and we'll stop again in a couple of minutes.
I'll just touch on those conditions overnight. This is from a drift study that I did quite a few years back now, but often they're quite expensive and complex to do, so we didn't get the opportunity to run some more. So this was done in Millie, that's between Ballater and Narrabri, I think, if anyone knows that part of New South Wales. And what we did was spray a 55 hectare block at 2 times. One which I'm calling night time at 2:30 in the morning, and the other one was daytime, or in the morning at 7:30 when the wind speed had gotten up. And what we've done is measured the deposition, in other words, how much product lands on the ground in the paddock as a reference point for our applied rate. We measured that on the ground for literally 1.5 kilometres downwind. We also had a tower set up with fine strings 20 metres high to catch that airborne fraction. So any droplets are in the air 80 metres downwind from the edge of that spray field, who were catching them and working out where they were. Now, sorry, that's a little bit fuzzy, but what we try to do in this trial is to actually match temperature and humidity as much as we can, so that evaporation is as close as we can get it in practical terms in the field. Our nighttime wind speed was 11.6 kilometres per hour, which is just above that minimum that's required. The daytime was 18.3. This graph here on the axis, this is the actual percentage of the applied rate that we caught on the string. So what was in the air 80 metres downwind from that spray paddock from a 55 hectare block. Our daytime amount was about 0.3%. Our nighttime amount was 1.6%. It was actually a 5-fold increase in how much product remained in the air. So that's a little bit concerning. But the other thing about this daytime amount that we captured there, that had all settled on the ground within 300 or 400 metres, and we could account for it. That amount in the air at night, there was nothing on the ground beyond 100 metres. So that what was in the air at 80 metres stayed in the air for the next 1.5 kilometres, travelling at 11.6 kilometres an hour, which, as I said, in 4 hours' time, that could have moved 40 kilometres away. And I guess the big thing is not always just a single applicator. If you get into a district where we've had a break in the weather, basically everyone's going to be out spraying at about the same time. And if we're all leaving those small fractions in the air, that's what can actually add up to quite a bit if it moves to the wrong place or it moves off target and then drains with the catchment into a particular spot. And that's certainly where we've seen a lot of... Sorry, go ahead, Pete.
Yeah, I mean, that's quite something, isn't it? Because if you look at that, the nighttime wind speed of 11.6 kilometres per hour, you could think that that is enough to get that turbulence. But is this the fact that that nighttime wind is more that laminar flow rather than the turbulent flow than you get it in the daytime?
I think that's right on the borderline, but what had happened in this instance is the wind speed dropped out for a couple of hours around sunset and then picked up again. So you need that wind speed to be continuous through sunset at about that speed to be safe. If it's actually dropped out and picks up again, I'm not sure what a safe wind speed would be.
And that's so it's really going to be hard to pick a safe nighttime spraying, isn't it, is what it all adds up to.
Yeah, particularly in areas where sensitive crops are grown. It's very difficult to know exactly when it's safe. And I know people will be tempted to do it to get over the country. If you're going to spray at night, that's with a standard course. If I'd actually gone to an extremely coarse, that would be down here. I could take 90% of that out of the air just with my nozzle choice, and probably 95% of it out of the air with nozzle and adjuvant.
Right, and I'm guessing that's where you're heading next, so I won't ask the obvious question.
I'm hoping to be heading there pretty soon.
Okay.
Obviously, spray quality does have a big role. I mean, a standard coarse spray quality generally has about 10% or less of what you put out that could stay in the air. So that's what we call small droplets, about 150 microns in diameter, or micrometers. You go to extremely coarse, you can actually get that down to less than 2, ultra coarse less than 0.5%. But the trade-off is going to be a little bit of efficacy penalties there. So there are a lot of nozzles out there, and I just want to talk a little bit about the adjuvants and a little bit about on judging spray quality. And obviously, Pete will give me a wind up if I go too long, but this is through an air induction nozzle. So we got some water at the top, an emulsion or EC type formulation. Some of these drift reduction adjuvants now have guar in, your modified seed oil types like your Hasons, and then you get other drift adjuvants like polyacrylamides. The way that an adjuvant or a formulation will change droplet size by changing how this pattern is formed. So an emulsion will actually make the droplet size much more uniform. If you put something like a non-ionic wetter in there, it'll make the droplets much smaller. Some of these other products obviously cause a sheet to be much thicker and the droplets get bigger. This is just an example. This is actually a measurement from a wind tunnel with 3 different nozzle types. So we have an AOXR, an air induction, the old normal flat fan, and a turbo T with each of those different adjuvant types. You can see that your XR type does change a hell of a lot just due to adjuvant in there. The air inductions, like the AOXR, don't respond as much. They're already a much lower drift. And so your nozzle choice is the first step in cutting down drift. Then your adjuvant choice will take a little bit more out there. But the whole point of an adjuvant is also to give you efficacy. So you've got to balance those two things out. Just want to mention the GRDC nozzle charts. There was a new version of it released in June, and it's just been recently updated because we have a couple of standards that they give spray quality against. There's a British one, the BCPC, or an American one, the ASAE. And the American one has a new standard that came out a few years ago, and some of the nozzle manufacturers are now reporting against that. And I guess the difference is that a lot of the data in the older charts were based on putting water through the nozzle. The new standard actually requires a particular adjuvant to be put in there to better reflect the tank mix, and that has caused some changes. Sorry, this is a little bit fuzzy on that side, so don't worry too much. Other than that's a turbo twin jet, but on the old data, it might have been coursed to 3 bar. Now it's only coursed to 2. If I go across to the AIXR and that particular size, you know, that would have been coursed up to 4 or 5 bar. Now it's only coursed to 3 bar. So anyone that's buying new nozzles, just get hold of the current chart and check it before you purchase to make sure everything's still right, because a lot of manufacturers are now reporting against this new standard. In other words, they're putting in the particular adjuvant in before they get their nozzles tested, rather than just having water. And that'll give you a better reflection of what the tank mix is actually likely to do. So one easy way to pick is if the chart's under the new standard. The new standard actually includes a thing called ultra coarse, these black ones. You can see a number of nozzles there are reporting against ultra coarse. So TJet have, Hypro have. There's a number of manufacturers that are actually reporting against this at the moment. So I guess the take-home message is there. If you're getting a new set of nozzles, make sure you get the current information to check their spray quality against. These are available from the GRDC website as well. What I was mentioning before, and this is an example with an air mix O2 nozzle or air induction, that, you know, some nozzles will respond to adjuvants and tank mix, but, you know, with water alone or glyphosate in there, you know, there's been very little change in the percent of volume that could be considered driftable. If you add a product like Collide, activator or a similar sort of thing, your old Ally 700, you can cut that down a little bit. If you add a non-ionic wetter in there, a wetter 1000 product, you'll actually increase drift potential. And I guess so the adjuvant choice does make a bit of difference, but the nozzle probably has a much bigger impact. I'll just point that out with one graph here. This is, again, a range of different nozzle types tested at Gatton CPAS a few years ago. This line here that's going up is a measure of that per fraction of small droplets produced. So your flat fans are up here around 40–50%, your mediums get around 20%, your coarses down under 10, then you get something like an extremely coarse. You know, that's less than 0.5% that could physically get in the air. So from a drift reduction point of view, that nozzle's fantastic. That's actually the sort of thing that they're using for dicamba applications in the States. I won't say too much more about that. But so drift's one thing, but efficacy is another. So that nozzle, sorry for jumping about, that's a TTI or a turbo T-jet induction. And probably one of the better nozzles, that and turbo drops, will get you down there on our market, maybe a ULD from Hypro. Just want to point out what consequence that can have on efficacy. This is in a study we did looking at some of the effects around the machine. So we actually assessed efficacy in the standing stubble because that's the most challenging place to get it. We looked in the center of the machine, just downwind or adjacent to the wheel, and out on the boom. We tested 3 different nozzle types at 2 speeds. So we're looking at 20 kilometers an hour versus 27, a couple of courses, and an extremely coarse, specifically on the weed control in that strip. I mean, you can hit it, anyone can hit what's out there. It's in here where all the action is. I guess a really quick take-home summary of that. At the higher speed of 27 kilometers an hour, there was a 10% reduction in the center of the machine compared to spraying at 20. And most people may or may not see that in the paddock, but over time that will build up. And the second point is that when we went to those extremely coarse, it actually resulted in a 10 to 12% reduction in the overall efficacy at either of the speeds. So going to really big droplets, there can be an efficacy penalty, particularly if you've got small targets, or small vertical targets, or particularly harder to wet prostate or broadleafs like wireweed, things like that. So if you're spraying during the day, normally a coarse spray quality would be well and truly good enough if you've got, a 300 metre or more downwind buffer. If you're going to spray at night, that coarse nozzle is not good enough. And if you move to something like the extremely coarse to cut down that airborne fraction, there may be a bit of an efficacy penalty for doing that. Because at the end of the day, you might be able to get similar coverage, but when you look at these really big big droplets, they may not stay on a lot of weeds. Bigger broadleafs, things that are easy to wet, not bad. To get that droplet size to work well on smaller targets would require much higher volumes than most people are used to using. Any questions there, or should I take a break for people to catch up, Pete?
Yeah, well, there's none coming in, Bill, but that's just got my mind spinning a bit, that last couple of slides, because it makes me think that, okay, I mean, I'm sort of out there telling people to slow down at harvest, and you're telling us to slow down while we're spraying, and this is a common message, and obviously growers have to get over the country. So I guess my first question in relation to speed is it just a matter of just in general driving to the conditions? So you've got that high stubble load, then you really need to make sure that you're traveling at 20 kilometers an hour. But then again, if you have other field conditions where there's not the big stubble load, it might be out of a pulse crop or something, you could go that bit faster if you've got a bit more bare ground. Is that a reasonable message?
I think you're right. I think it's weighing up what's in front of you. And I like having things like water sensitive paper, or the ability to use it just to see what effect going a bit faster or slower has on coverage. But to use something like water sensitive paper, you've got to start with a droplet size that'll stay on the thing you're trying to hit. And that's probably the challenge. I've got a couple of examples there. I'm not sure if you guys will be familiar with SnapCard, but you can certainly use it to measure the percent covered on water sensitive paper. And I'll just put up a couple of short examples, a couple more slides, and then I'll do a summary if that's okay.
Mm-hmm.
So this is some work that Bill Campbell did over west, looking at penetration into some lake canola as an example. Now, both of these sets of cards are exactly the same nozzles, same application volume, just a drop in speed. So this first one is at the top of the canopy, middle and bottom at 27 k's an hour, slowing down, which has dropped the pressure and increased the droplet size, probably on an 03 nozzle, I'd say. But you can see the increase in coverage, just changing speed by 5 kilometers an hour can have. Unless people are out actually looking at this for themselves, they probably wouldn't believe how much small changes in what they do can make on how much product you get to where you need it. And to take, I guess, one extra example there, this is some work done in South Australia. So this is in the strip of front harvested versus really low harvested and baled residues. at 50, 100, 150 litres per hectare. The difference, well, the amount of stubble makes, can be huge in terms of how much penetration you're getting. And so using cards for that type of thing, or comparing two speeds or small changes in volume, I've been doing this for years, and it's the quickest way to convince, you know, yourself as an applicator of whether what you're doing is better or worse. And so I like these as a tool, but the important thing about things like water sensitive paper is selecting a droplet size that suits the product and the target to start with, and then play around with things like volume or speed. Because while you can get really good coverage on a card with really big droplets, doesn't mean they'll necessarily stay on a small weed or a ryegrass or something like that. So yeah. I'm trying to balance out. Oh, sorry, go ahead.
I was just going to say, with those with the spray cards like we have there, I mean, I agree they're fantastic, and I can look at them and think, oh, I think that one there is about right. But when you use snap card or whatever, and I know this is a how long's a piece of string question, but what % coverage are you looking for? And I know it depends on the product, but in general, what % coverage are you looking for with snap card before you sort of say it's okay?
I generally have 3 groups I work with. So for fully translocated products like your glyphosates and group I's, about 6 to 8%. You know, as that's the sort of cutoff. Anything above that is usually pretty good.
Mm-hmm.
When I go to contact herbicides, I'm looking at 10 to 12. Anything above that again. And then when I'm looking at fungicides and in crop, I'm actually, particularly protectant fungicides, looking for about 15% plus.
Righto.
And they're my rules of thumb over about 20 years of working with insecticides and fungicides, and obviously more than what last decade with herbicides. The only one I really struggle with is obviously your pre-emergence, because there are so many factors in terms of, you know, solubility, incorporation of soil moisture. I just say get it as good as you can, but obviously, you know, 15 to 20 is probably a nice place to start with pre-emergence soil applied.
Okay, I think I might get those rules of thumb from you, Bill, and we'll do something with them with the WeedSmart website, because that's very valuable info, and nothing better than 20 years of experience.
Well, certainly, I know in New Farm's R&D program, we're looking to better validate those, and also, you know, just to get a clearer, what's a clear, consistent cut-offs in different sort of situations. So to get that in a replicated way might take us quite a few years, but I think the rules of thumb are pretty robust.
Yeah, excellent. Well, we've got a couple of questions, but I'll let you, I think you just about finish your slides, Bill, and then we'll finish off with some questions at the end.
Yeah, I guess there's only the 2 main slides left, and that's just reinforcing some of those take-home messages from the start. And that, you know, from managing drift, particularly over summer, you know, choosing the products carefully in the tank. That includes not just the active, but, you know, your formulation type. Obviously, Tom would have talked about volatility risk and things like that. Well, your amine-based products other than dicamba are pretty safe. And obviously your adjuvant that you put in there as well may increase or decrease the risk. You know, the whole point of spraying is to get good control. So understanding the product's mode of action and coverage requirements is important. If you can use a coarser spray quality, it'll give an acceptable level of control. And there are situations where you can go to extremely coarse. But again, I use that as my get out of jail nozzle, almost a nozzle you should use when you probably shouldn't be spraying. Always anticipate that you know, surface temperature inversions will form later in the day and likely to persist at night. But I guess the key message there is that air movement at night is very different to what it is during the day. When you spray during the day, your droplets will come back down, provided, you know, you've got enough wind speed. At night, that doesn't necessarily happen. So you can use forecasting information, particularly for wind speed and direction, are probably the 2 most accurate things you can get out of the Bureau, and other setups like spray-wise decisions from New Farm. that morning when you start, making sure you have enough wind and there's a little bit of heat in the ground with a clear direction is really important. We talked about that boom height earlier, just small increase in boom height, particularly when you're using a medium type droplet, or the smaller droplets can get in the air. They will get a lot more of those airborne if you lift the boom. And just to give you an example, so a 200 micron droplet, which even with a coarse spray quality, you're going to have 5 to 10% of your volume that comes out of the nozzle in that size. Anything smaller than that's not going to travel more than about 50 centimeters to a meter maximum. So if you're setting with a boom really high, they don't make it to the ground, and anything under 100 microns never even makes it to stubble or a crop canopy. So that 50 centimeters above the target on a 50 centimeter nozzle spacing is really important if you've got 110 degree nozzles. I mentioned the effects of speed, not only on what actually gets left in the air, but also can have an effect on efficacy, particularly around the machine. I don't think it's a sin to leave an area unsprayed if the wind direction isn't critical, provided you're going to have the opportunity to do that at another time. Otherwise, you might need to consider things like extremely coarse droplets to be able to spray those. And the last one is being able to continually monitor the conditions while you're spraying, particularly as you get later in the afternoon and into the evening. The most important thing to monitor is that wind speed, because if it drops out, you know that you're getting into conditions that are going to keep stuff in the air for a long time. So yeah, probably rabbited on a bit longer than intended, but happy to take any more questions for the time remaining.
Oh, that's perfect, Bill. We do have 10 minutes left. Just I remember a quote from one of our past Bayer reps up this way. Actually, he used to say, "Are you going spraying or are you going killing weeds?" If you're going spraying, you don't have to worry about the conditions or the weeds or the nozzle or the speed or whatever. But if you want to go killing weeds, you've got to get it all right, and that's exactly what you've covered. So yeah, I just always thought that was a great quote to get it in your mind that what you're actually doing out there is trying to kill the weeds. It sounds obvious, but we can forget it sometimes when we're just trying to get the job done. Yeah, I do have some questions for you, and there's a diverse range of questions. Firstly, Jack asked if we can get a copy of this information, and yes, a recording of this webinar will go up on the WeedSmart website later today. So we'll tweet that, and others can find it on the WeedSmart website. Now, an efficacy question from Kelly. Have you done any work? Sorry.
Can I add one more thing to what you just mentioned before we leave the first topic?
Yeah.
And that is on the GRDC website in the Grow Notes National section, there's a technical manual on spray application. There's a whole chapter in there on managing spray drift. There's another one on assessing deposition. And there's 21 other chapters on different things about spraying and different setups, as well as some of their fact sheets, and the nozzle charts also up on the GRDC website.
Yeah, thanks, Bill. I've had a look at that Grow Note. It's so comprehensive. It's amazing. Well done to you and others putting that together. I think there's 80 odd short videos in there, isn't there, that explain everything, which is, yeah, it's really great.
Go ahead.
No, you're right.
No, I'm good. I'm good.
Okay.
Next question.
So, the next question. So Kelly asked in regards to, sorry, I just switched this phone off. Kelly asked in regards to self-propelled boom sprays. Have you had a look at moving from 3 metre to 4 metre wheel spacing and how it affects the airflow under the self-propelled machine?
I haven't done that in a trial sense, but where I've seen actually the biggest improvement is on the guys with adjustable setups, where they push the front out to 4 and the back, leave the back at 3. That actually leaves the best deposition in either wheel track. So better than running at 4 or running at 3 was actually having the front wider. I know a lot of the guys around the Mallee and on a lot of the dusty country over summer on the machines where they have the ability to do that, a lot of guys will run that way.
Well, that's counterintuitive, isn't it? I thought if you had more wheel on the ground, you'd create more dust and more problems. But have you got any feeling for what's happening there?
I think it's probably partially that you only got one footprint on each wheel track, so your front wheel's not loosening it up and getting stuff airborne. And when the two are probably not directly in alignment, it may have a different aerodynamic effect on it. That's probably the best I can answer that. So the original question, did we answer that to an extent?
I don't think so. I think you said you hadn't measured it. So they're asking if you go out to 4 meters on your wheel spacing, does it affect the airflow under the machine?
Yeah, I can't answer that one directly. As I said, we did one quick comparison with them spread, but yeah, I don't see a lot of difference between 3 meter and 4 meter machines in terms of what they do. Like I've tested about 400 setups over the years, but not put those as a direct comparison side by side. But in terms of the effects of travel speed, and that you see similar things across both of them, across 3 meter and 4 meter machines. And they seem to occur at about the same speed, which with an SP is probably around that 20-22. The thing that probably makes a bigger difference is actually the height or the clearance above the ground relative to how far back and how low the boom is relative to the chassis.
Yeah.
So if you have the boom further back and lower down and in clear airflow, there's less effect on where the spray deposits and what they do.
Yeah. Okay. Next question, Bill. What about air-assisted booms and lower water rates? Have you got any thoughts on those?
Have we got another hour?
No. Well, maybe we need to do another webinar on just that topic. No, we don't have an hour. We've got 6 minutes, but have a swing.
Okay. In brief terms, smaller droplets are going to deposit better with air assistance. Larger droplets, not necessarily. So when we talk about air assistance, there's a couple of versions of it. So you do have the old Hardy Twin Force, or the new Hardy Twin Force, which is basically an airbag over the top of conventional nozzles. That is true air assistance, where the air is used to transport droplets actually made by the nozzle. And so you can change droplet size by changing the nozzle like anything else. Then you get into sort of hybrid air shear systems where there's a combination of air going through the nozzle. So you've got the air tech and airmatic type systems, and the airflows in those can be adjusted and produce a range of droplet sizes. And then you've got the Miller spray air, and that's a different version again, where you've got higher speed air actually shearing a column of liquid or stream liquid. And they're really good at producing small droplets in uniform droplet size, but less good for producing big droplets. And so for in-crop spraying fungicides and insecticides, I think, and a lot of canopy to catch stuff, I think they have a really good place. I'm just not convinced that spraying herbicides, either pre-em or into fallow, that is the best system available.
So if you had to choose one boom spray and you had a choice between a conventional boom and an air-assisted one at the moment, you would choose a conventional.
I think if my most critical applications during the year were my fungicide applications and applications in the crop, I would choose the air system. But if my most critical applications were actually getting consistent low drift herbicide applications, that's pre-emergence and that type of thing, I'd probably choose a conventional.
Righto. Okay, just a couple of minutes left. We've got another good question here. Now, many people have changed to TTI nozzles for using 2,4-D. Would you be comfortable using this nozzle for the double knock with paraquat? And if so, what level of reduction in efficacy could we expect?
Okay, I think depends on how you go about that. So my experience with using TTIs, say in areas adjacent to cotton systems, is that in the first knock with a fully translocated, we'd use them at 50 centimetres at say 50 to 60 litres, hopefully 60. And then if you're going to put a paraquat on the second, you come back at 25 centimetres and do it at 100. And generally, I've not seen reductions in efficacy as a result of that sort of strategy. But, you know, that's also into typically what are lower stubble environments. Where TTIs get challenged is the more standing stubble you have, the more interception and shadowing you'll get. And that's where you need to start increasing application volumes, but be aware that when the droplet size is that big to start with, that there will be some targets, particularly small grasses, or as I said, some harder to wet broadleaves, where you may get some reductions in efficacy. But I guess the beauty of a double knock is it does help, you know, cover up some of those initial ones, I guess, or take out stuff that might have been missed in the first pass. It's always a good idea when you're doing double knocks, regardless of the nozzle you have on, always, you know, drive in the opposite direction each time to overcome shadowing. But if it's really critical and you've got a reasonable stubble load there, you may be better off coming back in droplet size a little bit and just saving those ones for putting buffers in. Or if you're going to do applications in the evening, you know, they're the sorts of times where using that sort of nozzle would be critical.
Righto. Yeah, well, thanks very much, Bill. We're going to wrap it up there. We've had a good group on and lots of great questions, and I've certainly learned an enormous amount, and hopefully everyone else has as well. So, so thanks very much for joining us, Bill. That yeah, it was just very informative. I know that this topic is you could speak for another 3 or 4 days and still not be quite finished, but generally speaking, I think we've covered a lot of ground today, and yeah, we're very grateful, and this will go up on the WeedSmart website, and also we'll grab a couple of other of your pearls of wisdom for the WeedSmart website as well. So yeah, once again, thanks, Bill, and hope you have a good day.
All right. Thanks everyone for joining us. Thanks, Peter.
Righto, and that wraps it up. So that's our last WeedSmart webinar for the year, everyone. Thanks for joining us. I can see a few familiar names that joined us last week. I think this has been a great series talking about drift and summer spraying just as we lead into summer. Hopefully that's been very valuable, and yeah, we'll be back next year with some more WeedSmart webinars. If you have any topics in mind, make sure you let us know, and we'll try and cover them. But for now, thanks very much, and this is the first time I've done it this year, but I wish everyone a Merry Christmas, and we'll see you next year. Thanks very much.